Hello again, everybody. This is a tutorial about, I guess, the best instruments that I recommend for automotive and basic electronics equipment. Before understanding meters and things like that, we have to understand the most important factor of a meter before you go and you spend hundreds of dollars. We have to understand, in order to get accurate measurements from a meter, there is a factor, a variable called input impedance. That input impedance is important. With digital meters nowadays, really, it's a high input impedance, meaning it's 10 mega ohm, 10 million ohms. Why is that important? Because when you put it across a circuit, the meter is in parallel and it loads down the circuit. And why is that important? Because you will get different measurements than you're supposed to. The measurements will be inaccurate. So therefore, you try to choose a meter which has the highest input impedance. The Fluke, the digital meters, they all have 10 mega ohm input impedance. That's the most important thing, to make sure you get accurate measurements. Again, I'm not looking for a difference between 12.2 or 12.3. But if the circuit has 12 volts and I take a meter from Home Depot or somewhere like that, a $5 meter, and instead of 12 volts I measure 11 volts, that's a problem. You get what you pay for, like they say. So therefore, what I recommend is first understand the concept of high input impedance. That's what we want. The Fluke meter that I represent here in the video that I'm displaying is the industry standard, meaning it has been used in manufacturing, in engineering, all over. It is absolutely the epic of meters for its accuracy, for its features, for its functions. I will not recommend anything else but a Fluke. Now, this is an old Fluke. As you saw in the videos that I made, I had a more upgraded version, which is a very expensive meter. Again, to my viewers, I'm not going to go and tell my viewers to spend $1,000 on meters and test equipment and $3,000 for scanners unless you really understand what you're looking for. It doesn't make sense to spend $3,000 on a scanner if you do not understand the parameters of the sensors. Might as well just get a code reader under $100. It'll tell you mass airflow sensor, fine. There is no reason for that. So therefore, when I looked up this Fluke 83, you could get it probably for $120 or something like that online. Just not really that much, because the other ones go for $500, $600, and more than that. And obviously, if you're just starting out and you just want to do just basic measurements and you're not familiar, this will suffice more than anything. I guarantee this meter will help you with accurate measurements and features that you need. As you can see, in order to use a meter, we have to take into consideration the features that it has. Now, as I said one time, measuring current, I'm a big fan of measuring current, not just voltage. So a meter nowadays has a pickup coil or a jaw that you could put around the wire. For example, you see the jaws of this one. This is a big jaw. This comes with the Fluke. I'll get back to it in a second. This jaw is big. Okay? This goes up to 400 amps. This goes up to about 200 amps, DC, AC. This jaw is much smaller and compact. That means I can get into small locations where there's a lot of components and things like that. I can measure with this one. This one might be a problem because the jaw is a little too big to fit. And I might have a limited amount of space, especially in automotive and engine and where the pulleys are. So therefore, it's a little too big. However, 400 amps is great compared to 200 amps. What do you need that? Well, you want to know how much you're cranking, how much depending on the V6, V8, you're going to be cranking maybe 200, 300 amps, whatever you're cranking. You need more than 200 amps. So therefore, not this one is an attachment to this, and believe me, it is not cheap. That's why I do not recommend this for the beginners. I recommend somewhat like this, but like I said, I got it in an auto shop and I haven't seen it since. But there are similar ones to this. This one, if you understand what the function is, it goes by output 1 millivolt per amp. This attaches to this one, this fluke meter, any fluke meter. Millivolts now is going to correspond to an amp. So I will put this in here. This goes in here. This goes in here from this. And you put it on millivolts, not volts, because we're using the millivolt scale. See, it says millivolts. So 1 amp is equal to 1 millivolt. If I have 400 amps, that means I will measure 400 millivolts. 400 millivolts is 400 amps. 200 millivolts on the scale will be 200 amps. If you're good in converting, then you can use a meter like this. But if you get confused, for the beginners of the viewers, I will not recommend such a thing. I will only recommend something that's straightforward. That's why I recommend something like this. Again, different company, different manufacturer, doesn't matter. But this will tell you right away how much you're measuring. And as I told you before, it tells you AC, the display, AC, DC, volts. You see the amps? The A in the right corner, that tells you you're measuring amps, AC amps. So it tells you, when you put the dial, the selector, what you're measuring, which is what I like for beginners, for viewers, so they won't make any mistakes. Like here, DC volts. It tells you you're measuring DC volts, what the dial is. Many of them I saw, like I made a video, they don't tell you. Even though you put the selector on DC volts, this display will not tell you DC volts. You'll just see numbers. And to me, to a beginner who's not familiar with these things, it is confusing. Therefore, that's why I recommend these things. Auto means it'll automatically go to the range that will give you the best decimal display. So let's say if I measure the battery, which is 12.61, it'll give me a display that will give me 12.61, meaning it'll give me the best decimal. I don't want 12 volts on a battery. I want to measure if it's 12.1, 12.2, 12.3. If you're at 12.2, you're already at 75% charge. So I want to know, is it 12.5? Is it 12.6? Is it 12.7? This will auto range, and you'll see it when it goes to OL. It'll automatically select the best range for you. That's what auto is. You could do it in manual also. Why do it in manual when you have auto? That's why these features are good. Now, as I said before, this is an attachment. This is a little too big, like I said, the jaws, but you can measure more current. This is less current, but the jaw is smaller. It can fit in better locations. When I made a video about the alternator, I wanted to measure the output of the alternator in current. As you know, I'm a big fan of current, not voltage. But current tells me a lot about how the circuit is performing. So therefore, when I measured that red thick wire coming from BAT going to the battery, from the alternator to the battery, I measured how much current is being drawn by the alternator when I put the lights on, when I put the lights off. I saw the current changing. So, not just the voltage. Many people will go and they'll say, the alternator is good. Look at the voltage. On the gauge, it says 14.1 volts. That's fine. That's great. The alternator is working. Not necessarily. You have to measure ripple voltage. On the waveform, you have to look at the current. And that's why when you have that thick wire, that fat red wire from the alternator going to the battery, I want to measure the current. Remember, there's a regulator in the alternator. keeping the voltage steady. However, I don't know the current. That's why I put this across the wire, and it told me exactly how much I'm drawing. So let's say this was the wire from the alternator to the battery. It would be a red wire. I put it across this, and I put it on amps. This is AC. Expecting maybe 200 amps. It would tell me how many amps I was drawing. Now you're going to ask me why DC? Because the alternator is an AC generator, 3-phase. It changes it with rectified diodes to DC. So in that example in the video, I measured how much current was going when I put the lights on, when I put the blower motor on, when I put all the accessories on, and I saw the current changing. That's why I like such a meter. Getting back to this one, I said this is the standard of the industry for anything, for automotive, for anything. This is something I can swear by. You have some features over here, just like you have over there, and I want to point it out to you. Another thing is, when I have problems with circuits, automotive, I like to, sometimes, if you have something that's loaded down or pulled down, let's say 12 volts is measuring 9 volts, I like to use an outside source, not the battery, to give me 12 volts. What do I mean by that? A power supply, a DC power supply, I use, and I made a video about this, however, I'm going to elaborate on it. A DC voltage supply will give you a voltage that you need from 0 to 12 volts to 20 volts. So therefore, I can crank, in this case actually, 60 volts. It is a variable power supply. Do I need 60 volts? You're probably asking, of course not. The circuits don't use 60 volts. The circuits use 12 volts. However, some circuits use 5 volts as a reference voltage from the PCM to the sensors. Let's say there's a loading down. You know what I'm going to do? I'm going to inject my power supply and bring it down to 5 volts and put that 5 volts to that circuit with all the sensors that have 5 volts. So, and then I know I have a good 5 volts going in, and then I can measure the outputs and the signals. Whereas the car battery is set at 12 volts. I cannot make the car battery 5 volts, 6 volts, 7 volts, 8 volts. It is set at 12 volts. This power supply gives me another weapon, another tool for troubleshooting, that I can change this dial to whatever voltage I need. If I need 9 volts, I'll put it to 9 volts. If I need 5 volts, I'll inject 5 volts to the part of the circuit that I need. It is a good known reference voltage that I'm using. And you will not see this on YouTube. I don't think anybody even does this in automotive. Again, if the PCM has 12 volts, but it's being loaded down by sensors or the PCM, that 12 volts will now be 9 volts or whatever, or 10 volts. What am I going to do now? Well, you know what? You have to look at the circuit and try to find a place where you can inject 5 volts. Now, as I said before, the features. I want to go through the features. This is why I recommend this. Again, about maybe $120, something like that. Again, I'm not going to tell my viewers to spend $400, $500 if they're not familiar with features and automotive test equipment. It doesn't make sense, right? It's like a doctor who doesn't know how to take blood pressure. He's going to buy all kinds of X-ray equipment and things like that. If he doesn't know how to use it, what good is it? We have whatever we know, we have to use. So now, you see the features over here. Range, that's for manual. This is the light. When I press this, the light becomes illuminated for the scale. Now, when you see the blue, a blue here, blue here, blue here, that means this is DC. And I can change this to this pattern that I need over here. So in other words, this is capacitance, which we're not going to test anyway. When I put this on, I'm selecting this feature over here on the side. DC or AC microamps. DC or AC milliamps. That's great if you want to put the meter to measure current. But the other factor is, why did I recommend such a power supply? Look, current. It gives you the current draw. So let's say when I hook up this to a PCM or something, I know I measure 12 volts. However, I don't know how much current I'm drawing. This will tell me how much current I'm drawing. If I'm drawing too much current, I will see it on the display. Again, this only goes up to 1.5 amps. You need maybe 10 amps, 15 amps, and they go up in price. They're costly. Power supplies that give a lot of current. But if you really know what you're doing and you're going to be in the industry, and this is, like I said, you will not see this anywhere else. A variable power supply is expensive, but it will tackle many problems in circuits, especially electronic circuits with computers. Highly recommended, but expensive unless you're really going to be in the profession. Otherwise, I will not recommend it for the everyday use. But for the one who really wants to troubleshoot, tackle tough problems, this is use a power supply with current to tell you how much current. Now, as you saw over here, I mentioned something. The reason I like this, as you can see over here, there's something called a hold button. When you get into very compressed areas in automotive, very small areas, it's hard to put your probe, especially where you have pulleys, belts. You're afraid, obviously, of injury and things like that. You want to go and just measure something very quickly and take the probe out. In the usual case, when we take something and we measure something, this is 12.5. If I take the probe out of the power supply, I lose the voltage. Correct? Now, this gives me another function. I will put it on hold, put it in memory. That means the number that I get when I put it in will be held in memory. It'll save it. So watch. 0, nothing. I'm going to put it in. 12.5. 12.58. Right? Watch. I'm going to take away the probe. Let's say this was a sensor in a very tight spot. Look. See? No probe. But the display is still there. That's the beauty of the meter. I just touch something, maybe it's a sensor, whatever, and that's it. And it holds it in memory. That's the beauty of it. You don't have to keep on holding your probe in that circuit, especially in a very tight spot. That's a feature which I love. So if I'm in a sensor and I want to measure 12 volts, I touch it quickly, right? I put the hold button, I touch it, my display stays there. That's it, it's a memory. That's a beautiful function to have. Now, let's take off hold. I want to show you something else. Now, there's another function. Sometimes you have numbers, they fluctuate. Let's say this will go 12.5, 12.6, 12.7, and it keeps on fluctuating, but I want to get a good number, right? Let's say it's going from 12.5 to 12.7. So the minimum would be 12.5, the maximum would be 12.7, the average would be 12.6. But I'm tired of watching the display going up and down, up and down. So what do? Let me put this in. There's something called minimum max. Max means the maximum. If you press it again, that's the average. Max, minimum. So in this case, what you see is the maximum is 12.6. The minimum is 12.2, 12.52. And it gives you the minimum, the least, the minimum, voltage, the maximum voltage, and what I like, it gives you the average. So what was the average between 12.6 and 12.52? 12.54. So therefore, you don't have to worry about the numbers jumping up and down. You can take the average, or you could take the minimum. Why do I like this feature? Because when you go and you measure and you crank your car, you know your battery voltage will go down. Roughly goes down to about 10 volts. However, it's hard to capture it on the meter because it happens so fast. Right? But when I use this meter and I put on minimum, guess what? It will give me the minimum that battery dropped to when I started the car. So if it's 10 volts, I'll put it on minimum, it'll tell me 10 volts. If it's 9 volts, which is not good, it'll tell me 9 volts. That's why I like the minimum function. If you don't put it on that, it'll be too fast, the display, to catch it. This will catch it. Also for frequency, you have hertz over here, Hz, if you want to measure from sensors, sometimes you have to measure frequency, and sometimes if you want to measure relative, means when you first thing is you always zero the leads. You should have about 0.2, 0.3 ohms. But that 0.3 ohms, if you want to subtract it, you put relative and it'll go down to 0, and it'll take that 0.3 ohms into consideration when you make a measurement. On high resistors, it doesn't matter. On low resistor, if you're measuring 1 ohm resistor, and I already have 0.5 ohms on the leads itself, I'll measure 1.5 ohms. I have to subtract 0.5 ohms. The meter does this for you when you put it on relative with the triangle, REL triangle. Again, highly recommend this one, or highly recommend this one. Highly recommend the power supply, so you don't have to use a battery. But like I said, this will cost dearly. So unless you're really going into the field and you're really serious about going into the profession,